As energy demand increases for everything from EVs to AI, we need bigger, better, and more cost-effective batteries. We can't keep depending on China, which accounts for over 90% of today's battery materials market.
The United States has fallen behind in the production of critical rare earth minerals used in everything from wind turbines to television screens.
That supply chain is subject to disruptions and rising costs, leaving countries, companies, and consumers vulnerable to increasing supply chain risk.
Right now, China absolutely dominates the graphite processing market, 100%.
The whole world is really reliant on China for graphite. Silicon, on the other hand, is ubiquitous and one of the most abundant elements in the Earth's crust.
However, silicon has this challenge of degrading much faster than graphite. So our innovation really centered around solving battery degradation.
Silicon has been a holy grail for the lithium-ion battery industry for decades now.
This is the story of an overlooked supply chain and the innovative technology that makes all American silicon the way of the energy future.
What we need to do is get back to our innovation roots, but also our roots of being able to support ourselves through the materials that we're making, through the jobs that we're creating. So it's been really great to be able to partner with Ferroglobe and really utilize those resources here in the United States.
Silicon is the second most abundant element in the Earth's crust and essential to the making of everything from aluminum to solar panels. It comes from quartz and sand, and unlike graphite and other critical minerals, it's in abundant supply in the U.S.
What we'll do is come in and strip off our topsoil, then you'll have your overburden, then you'll have your sand layer. We're trying to get down to the best rock, quartz rocks.
We put the soil back where it was in a new and better way. The farmers love us. We can make rolling hills for livestock, or we can make row crop land. This is just a really good example of how the community and mining work together in order to produce something that's needed.
Once the material comes to the plant, is put into the hopper, makes its way through the wash plant, clean, remove the byproducts, and is separated, and we ship it off to our furnaces. We have one located in Ohio. Just being a part of the whole process, knowing that we're starting right here, but it doesn't stop here, is a privilege and it's great.
Rather than building from scratch, the U.S. silicon supply chain already beats with purpose in the industrial heartland.
So in 1953, Beverly was established with 4 small submerged arc furnaces. 1970 is when we built this shop here. This is a small community, and we really take pride in having a family-based operation with such a great company.
I started here in the fall of 1987, right out of high school. I know a lot of people that grew up here, their dads were here, their grandpas were here. I'm very proud to be a blue-collar worker. I think it's the best thing you can be for America.
This is quartz gravel that we're using right now for silicon. We have 2 bins, we run 600 pounds a batch.
Silicon has this fantastic property of being super lightweight and being able to store 10 times more energy per gram of silicon than graphite. So this is a fantastic way of reducing your bill of materials, making a much more affordable, lightweight battery.
So we've been developing our solution for a long time, and we had to innovate on all aspects of the battery, starting with the silicon metal that we get from Ferroglobe, and then modifying it and then pairing it with all of the right ingredients to be able to make a battery that works.
People are going to see these batteries come about, and they won't just be in specialized applications. It's going to make everything more affordable, and I think benefit the American economy.
Building on the enduring promise of homegrown raw materials and industrial processes, Coreshell takes silicon through an innovative proprietary step that enables the world's best silicon anode batteries.
It's been a combination of many, many innovations, surface coatings, but also new electrolytes, new binders.
In order to make commercialization, we need two critical elements. One should be cheap materials, and the other is we have to have good manufacturabilities.
You would immediately recognize these in a full commercial setting. When we bring automobile partners through here, they can look at this and recognize what they have in their big factories, in their gigafactories.
We wanted to be 100% sure that no matter what technology that we were developing, that it could be integrated in off-the-shelf gigafactory scale battery manufacturing equipment. If lithium-ion batteries can be completely domestically manufactured, then I think we can realize the next chapter of great American industrialization.
So this is the final product. This is our final cell that's been tested and is ready to go to ship to our customers.
I grew up in Missouri, right? The U.S. has often led the way globally in creating those breakthrough innovations. And so to be at the center of that while connecting the dots to families and generations of industry that have already been sprung up and been a part of people's lives for decades is something that I take a lot of immense pride in.